Hi, my name is Thomas Kim. This is my third video in the series of scripting language videos. If you haven't watched my two previous videos, you have to watch it to follow with me. In this video, I will demonstrate how to use both Bison and Flex to create scripting language. I will create a new project. I will choose some Win32 console application, and the project name will be Flex. Bison and Flex will be my project name. I will select empty project, and I will make it as set as startup project. Then I will add one filter. I will then add new item. Then add another one. Okay, I added two files. One is Lexer L, the other is Parser Y, and I will make some changes at these settings. Again, I will make it to custom tool, apply. Then command line, it should be Flex O. File name, then identity, and output should be CPP, and additional dependency. About the macros, if you are not sure of the macros or the meaning of the macros, if you want to know, then you can click it to check. Here, identity is lex.rl, and the file name should be Lexer. So you can understand what it means. I have to make a correction here. Okay. Okay, everything seems fine. I will change it. Okay. I will make another settings. Right click, properties, custom tool, apply, then Bison O, name, CPP, once again, identity, then generating CPP, output should be file name CPP, and semicolon, file name HPP. Okay, let's check. Let me double check these settings. Okay, then I I will give you some explanation about the files. The Bison grammar file parser.y. This is Bison. This is called the Bison input file, or this is also called the Bison grammar file. And we created an empty Plex input file. It is called Lexer.l. And if we compile it, we generate the parser.c. This means output switch, and this is source file, Bison input file. And if we learn this command in the command line, then two files, parser.cpp and parse.hpp, two files would be created. These are Bison output files. .cpp, parser.cpp, it is also called the Parser Implementation file, and parser.hpp, this is called the Parser header files. And using Plex, we generate Lexer.cpp. This is called the lexical analyzer file, and it is also called the lexical scanner file, or just a scanner. And the main module, we haven't added it. Then let's see. Then in the generated parse.cpp YY-parse syntax, YY-parse function will be implemented in parser.cpp, and in the lexer.cpp YY-lex, this function will be generated. This function is called the lexical analyzer or scanner, lexical scanner, or simply we call sometimes Lexer. Then I will tell you details about how to fill the code here. And first comes lexical scanner file, or Plex input file usually composed of three sections. This section is called let me see. This section is called definition section. Definition section composes the first part before two % symbols, and the next section is called rule sections and user code section, the last section. Then this is declaration definition section. This is called definition section. Sorry. This section is called definition section. We usually put some options, Lexer options, Plex options here, but also some declarations. And this is called rule sections. Rule section usually have some lexical scanner rules. And this section is usually called user sections, user code sections. We usually put user code in these sections. So let's start. I will put some code here. Percent option no YY wrap, and in this definition section we can put some code here like tab, and every code in this section would be copied verbatim to the lexical scanner file generated by Plex. I will disable some warnings. and then %. Please note that this block of code is copied verbatim to generate a scanner file, and I would include some library, some include files here, or some macros. Parser.hpp is actually would be generated from this file, and so another one, then extern int yy parse. This function will be generated from parser.y using Bison. And I will declare some names, digits, then some regular expressions here. Note that this is called name, and name. This is regular expressions corresponding to this name. Then another one, minus, plus, then star. These are binary operators, and parentheses. About the regular expressions, I will explain about regular expressions in my next videos, in my later videos. And this is rule sections here. Digits, and this is action code for rules. These are match rule, and this is action of lexical scanner. Okay, before this I will do some code in parser. I would parser lexical syntax parser. And syntax parser also has 3 sections like this. The first part is epilogue. This section is called epilogue. This section is called syntax rule sections, and this section is called epilogue. Okay, I will put some prologue. This is rule section. Let's see. This is prologue. Bison option comes here. Then after this 2% symbol, grammar rules comes here, and after 2% symbols, percent characters, epilogue comes here. So in this I will put some text here. Define. This option is Bison option. It means generate include file. Parser.hpp will be generated with this option. Then also some include files. Then include CMS. I may need this file. Then extern. This file will be generated using Plex. This function generated using Plex. Another one is extern void yy error character constant point MSC, and we have to implement this file in the epilogue section of the code. This file does nothing. This file just prints out message. Then okay. Let's see. We have to define some code here. And semicolon here. This declares a semantic value type. This keyword declares semantic value type as union of variables. Then I create some tokens here. Tokens data type would be DB. Tokens semantic value type will be double. This DBL is actually this. This means token type is double. It actually means, and token name would be literal DBL. And I will create some groupings. DBL EXPR, and also type def type DBL and Tom. I will create another one. I will define start symbol. Start symbol is used to define the start of the root node of the tree, syntax tree. So start will be program. And this is rule section. I define here some rules of our program, our grammar, and it can be empty. And another rule for program expr and std shell $2 std and each grouping should end with a semicolon, and grouping should start should be unindented like this. And this has the first grouping has this is something like this. We can always use groupings this way. I could have written grammar like this, Note I ended the all statement, grouping statement with a semicolon. I converge these two grammar rule into a single one using pipe character like this, and removing this. This is to easy look, to understand easily. This is semantic actions. This is called semantic actions, and this is grammar rule. And $2 means the value of the second non-terminal. This is it. $2 actually means the value of EXPR. EXPR's semantic value is $2. Then I will add another rule. EXPR colon and term. I have to add term and semantic value. $$ is for the semantic value of EXPR. This is non-terminal. This is also non-terminal, but the grouping symbol, the semantic value of the grouping symbol EXPR's semantic value is $. We can access this way. And $1. The semantic value of term is $1. So we assign the semantic value of $1 to the semantic value of EXPR. And another one, EXPR plus term $. This $. Is semantic value of EXPR, and this $1 plus $3. Semantic value $1 in $1. It is like add two values, add the value of EXPR with the value of term and assign it to grouping EXPR. And I will add another one. Minus and minus. Then I will terminate it. Then another grouping term would be literal DBL, and its action would be $1. Type literal is actually defined as token. This is terminal. This is non-terminal. This is also called grouping. So the terminal literal DBL's semantic value is DBL. DBL actually is double floating point, and the literal DBL's semantic value is $1. And grouping symbol, non-terminal grouping symbol terms semantic value is $. And another one, term star and literal DBL $, times $3. I will add another rule. This time minus, and it should be minus. Okay, I terminate the grouping. As you can see, all groupings, all all groupings or grammar rule should terminate it with a semicolon like this. Another groupings, grammar rule, and with a semicolon, semicolon. And the $$ symbol is for semantic value of grouping term, and this $$ all implies the semantic value of term, and this $$ means semantic value of expression, and or semantic value of expression. And this semantic as $1 means semantic value of expression expr, and $3 means semantic value of term. Because this is $3, because the semantic value of plus, this is $2, so this is the same. And this is everything in the curly brace here is called semantic action, and this is called rule, semantic rules, and this is called non-terminal, and this is called terminals. Okay, then let's compile it. Okay, it compiled successfully. I will add existing parts. You can see, as you can see, parse.hpp and parser.cpp is generated. Okay, then I will go back to Lexer to finish. Let me see. When this is, then YYVAR and TBR as A2OF YY text. And another thing, I have to return it. Return literal TBR. This is semantic value. This is token. So every token may or may not have semantic values. Another Plex rule, lexical analyzer rules, would be EIN OPR. This I can simply return YY text 0. And another rule will be new line character return new line. And all other characters just ignore. Then let's try it. Let's compile it. Okay, it is compiled successfully. Then I will add the files. Okay. Then I will make some settings. I will disable pre-compiled header. Not using pre-compiled headers. Apply. Okay. Also not using pre-compiled header. Apply. Okay. Then I will add the main module. Okay. Actually, I don't need it. pass is generated here, but it will be also declared in HPP file. HPP file, we can add HPP parser HPP here. Okay. Then let's try to compile this. Okay. Then Lexer. Oh, you cannot open this file. You have to watch my previous video about this file. This file should come from it should come no. It should come from here. From this folder. This folder is defined as environment variable. I just wanna double check it. Okay, Bison plus inc. This variable already defined, so I can edit project C++ general additional include. I can do this. Okay. Then I will compile. Okay, everything seems to be compiled properly. I will run it. Then okay. Let me double check once again. Okay, it seems to be working properly. Yes. This is the way we first programmed. We used both parser file and the Lexer file. We used lexical analyzer. We used Plex. We used Plex to compile Lexer.l file. Let's see. I will show the diagrams. So parser dot is called Bison input file. Using this Bison input file, we created Bison output file parser.cpp. This file is called Parser Implementation file, and using this file we also generated the parser.hpp. To generate parser.hpp, we need to give options to define. To generate parser.hpp, we have to give options defines. Then using Plex input file Lexer.l, we generate Lexer.cpp. This is called the lexical analyzer file or lexical scanner. Then using main CPP defines main functions. So in main.cpp, in main CPP calls pass syntax parser, and the syntax parser calls lexical scanner lex calls lexical scanner. Each time, as you can see in the code, each time in the YY pass calls lexical scanner, lexical scanner to get tokens. Then it loops until it consumes all tokens. Then this is Bison input file, and this is Flex input file format. I will post this document in the internet for you to download. That's it. Thank you.